Hello guys, my name is SWADEEP and today we are going to talk about security in operating systems. So why security? At the time, there were few thoughts given to problems of security in computer operating systems. In most cases, security was provided by controlling physical access. Computers were huge things locked away in a room with lots of air conditioning. A user who could access a system was allowed to access any file and any program that was running. But this is not the case now. Now we are connected to the whole world with the help of the internet. Today, it is quite common to share access to systems, especially in our homes. Even when systems are not shared, they are connected to a network. In many cases, even at home, they are on a LAN. LAN is a local area network. This exposes our system to the external threats. So, what is security? Security is a measure of confidence that the integrity of a system and its data will be preserved. Security involves guarding computer resources against unauthorized access, malicious destruction or alteration, and accidental introduction of inconsistency. So, there are many reasons a code might be malicious. It is possible that the programmer was careless, but it is also possible that the programmer had malicious thoughts while making the application and wanted to harm your system. Now, this is just a basic 4-layer model of security. Here, the layers are application based, operating system, then the network layer, and the physical layer. In application layer, there can be attacks like logical bugs, then there might be design flaws in the application, and then you can inject codes in the application to get data. To prevent this, we can create sandbox of the application or create software restrictions. In the operating system layer, there can be insecure defaults and platform vulnerabilities. For this, we can create patches, we can reconfigure it, and we can harden the operating system. In the network layer, there is sniffing, spoofing, and masquerading. So to prevent this, we can encrypt the files, have authentication, and then filter the stuff. In the physical layer, there's console access, hardware-based attacks. For this, we can create guards, vault, and device data encryption. So now computer viruses. Viruses are portions of programs that insert themselves into other programs in a manner analogous to the way that biological viruses insert themselves into living cells. When a program containing a virus is run on a computer, the virus will insert itself into other programs on the computer. The computer virus can be sent to a person by attaching the virus to the mail. The virus can enter the system only when the app containing the virus is executed. For example, if the virus is there in a PDF, we have to first open the PDF so that the virus can enter our system. In the olden days, when software was distributed through floppy disks, the virus was loaded into the boot sector of the floppy disk. So when the laptop or the computer was booted, the boot sector would run from the floppy disk, and hence the virus would enter the system. Trojan. Trojans are programs that are not what they appear to be. This term comes from a technique used during the Trojan War, when one side appeared to withdraw and left a wooden horse with a team of soldiers. Then at night, the soldiers came out from the Trojan horse and then destroyed the other city. Similarly, here programs appears to be doing one thing and do something else. Worms. Worms are programs that are similar to viruses and Trojans, but are a little different too. They do not infect other programs and pretend to do something else. A worm replicates itself in order to spread to other computers. It often uses a computer network to spread itself. Spyware. Spyware is a special class of Trojans. It typically reports local activities to some unrelated website. In the most harmless case, this info might just identify which websites are being accessed and help user to show specific ads. In a malicious instance, spyware can be used to steal passwords to websites. Now, DOS attack. DOS or denial of service attack is the one where the user cannot access the machine or the operating system because of the stress. There are many such attacks like ping of death where you continuously send ping requests, and another is the SYN flood. Here you continuously keep sending synchronization so that it will create continuous three-way handshakes, but it doesn't reach anywhere, which causes a Denial of service. Now, buffer overflow. In order to do much damage, a virus server needs to somehow fool the system into running its code in supervisor mode. One of the most common ways that a virus or worm manages this feat is to exploit a type of program coding error called a buffer overflow or buffer overrun. A buffer overflow occurs when a process stores data beyond the end of a buffer. Now, protection. The OS protects the use of the CPU by starting a timer and preventing user programs from changing the timer. This allows the OS to abort any program that goes into a loop, intentionally or not. In batch systems, a runtime estimate is given when a program is started, and the program will be terminated if it exceeds that estimate by more than a certain percentage. In interactive systems, it is assumed that eventually the user will abort an operation and either retry it or do something else. In either case, a rogue program can't completely tie up the system since the OS is probably multitasking and the user will still be able to interact with the OS to kill a looping program. Another aspect of the OS protection is memory protection. The hardware can usually check the addressing bounds of the logical address space. In addition, many systems can mark certain pages as allowing read-only access or execute-only access, giving an added measure of protection. These features allow the OS to protect itself from any user program and also keeps programs from interfering with each other. Authentication. Controlling what a user can access on a system actually has two parts to it: authentication and authorization. Authentication is verifying the identity of a party to a communication. A new class of computer fraud has arisen that is known as phishing. A phishing fraud is most often sent in an email. It directs a user to a website that pretends to be something else it is not. Your bank, for example. Authentication usually takes one of three forms, that is, something you have, something you know, or something you are. Something you have can be like a house key or ATM card which you need to access something. Like house key is required to enter your house. Something you know, login ID and password. This is used in general logging into websites. And something you are. Retinal scans, voice scan, and fingerprints are something you are. It's only with you, and you need to be there to access it. Using two different methods of authentication at the same time is called two-factor authentication. This is seen when one uses an ATM card and must also supply a PIN. Authorization. Once an OS knows who an user is, the next task is to decide what operations that user is allowed to do. More specifically, the allowed operations depends on the object being accessed. Deciding what operations a user can perform on an object such as a file is called authorization. An OS can use an access control matrix which or access control list or a capability list. Now the policies. Any network that is to be secure must have a set of policies that clearly spell out several things. These are what users are allowed to do, what users are not allowed to do, what users are required to do, what the punishments are if the procedures are not followed. Backups. OS must provide a mechanism for crashes. You must be capable to recover the data from the crash. One way to do this is to create a backup. This data to a removable media. There are many approaches you can take to backing up a system, but there is one that works best. It involves the fact that most OSs have an indication in the file directories that show whether a file has been changed since it was last backed up. It is often called an archive bit. If files are on laptop or the media used for backup are often physically taken outside the facility, then using encryption on the files or the media is a sound idea so that if the computer or the backup is stolen, the data will not be compromised. An alternative to constant backups is the use of RAID disk, organizations which store duplicate data in the disk itself. Some of the RAID configurations provide substantially improved reliability at fairly low cost and mitigate the problems of losing due to drive failures. Now we had talked about the archive bit. This basically works like this. Whenever after backing up, the archive bit will become null. Then if it detects any change in the file after backing up, it will again make the archive bit 1 indicating that the file was changed, and since it has to be backed up again. File protection. With multi-user systems, the OS must also provide a mechanism to make files private. Privacy does not necessarily mean that only a single user can access a given file. It must be possible for multiple users to share a file. One way to do this is by specifying the access rights of the file owner, a group whose membership is defined by the system administrator and all other users. This can be done using chmod, a utility present in Unix and Linux-based systems. Now, communication security. A process running on a system has to communicate with a process running on a different system. The information sent across the communication link should be secured. There are three potential classes of problems. First is interpretation or reading the message while the transmission is taking place. Second is insertion or sending a message which the user was not actually sending. And third is changing the message. A protocol known as Kerberos has been developed for authentication. It is widely used, having become almost a de facto standard. Developing a protocol which is secure is very complex. Using these secure protocols allows us to be certain that the user we are communicating is the correct user. Encryption. Another class of algorithms has become developed for making sure that messages are not subject to any of the three problems outlined above. These algorithms are used to encrypt the messages between the systems in such a way that they cannot be easily read by a third party. If the message cannot be read, then it cannot be changed. Encryption algorithms take a message, which is known as plain text, and scrambles it with a special number called key. And scrambling the received message will reveal the original message and is called decryption. Decryption can take place with the help of a key. So for an interceptor to try to decode the message, he has to try all the keys, which would take a long time. Now, with the processors increasing in the capabilities, the time taken is becoming less and less. That's why even now if you see your Google passwords, they tell you to change the password within 30 days. Now, symmetric key encryption. When the decryption uses the same key as the encryption key, then it is known as symmetric key encryption. Here the key must be known to the sender and receivers. Here a problem is that we have to share the key, and thus we have to trust that the person we are sharing the key to is who we think he is. Another way to share a key is to use a trusted third party to generate the key and share it to both of them. Asymmetric key encryption. Other algorithms use a pair of keys that are generated together. One of the keys is used for the encryption and the other is used for the decryption. This type of algorithm is known as symmetric key encryption. Here one key can be known to the entire world and is called a public key. The other key is not made public and is called private key. Any of the keys can be used for encryption, but the others should be used for decryption. Hence, this can also be used for validating too. Now, message digests. In some circumstances, we don't necessarily want to hide the contents of the message. We only want to make sure that it didn't get changed. In such cases, we can compute a simpler, faster function known as a message digest or a hash. These functions chop a long message into short pieces and combine them with a one-way function, one that cannot be easily reversed. The result is a message digest of a fixed length, which is about 128 bits usually. By combining a message digest with public key encryption, an user can effectively sign a message electronically. User A will Imagine user A will take a message M and create a digest of the message. He will encrypt the digest with his private key and send both the message and the encrypted digest to user B. B knows A's public key and thus can decrypt the digest. He can then run the digest algorithm on message and compare them with the one received from A. If they are equal, then he knows that A sent the message. Now, certificates. A special use of signing of message is used to authenticate either clients or servers. This process produces certificates that verifies identity. A special program is run that produces a preliminary certificate. This preliminary certificate is then sent to a certificate authority, and the CA encrypts the certificate with its private key and returns it to the requesting entity as a finished certificate. An user can send this certificate to prove its identity. The security protocols. Security functions have been specified at different levels. In the TCP/IP protocol used in the Internet, security has been specified for both the transport and the network layer. If you are using the 802.11 wireless networking, then there may be Also encryption at the data link layer. The transport layer security features are defined in a protocol called Secure Socket Layer. This protocol is used between web servers and browsers for secure communication with an application level protocol called HTTPS. Security is also available at the network layer with a protocol known as IPsec or IP security. IPsec is a set of protocols developed by the Internet Engineering Task Force to support secure exchange of packets at the IP layer. It supports two encryption modes, transport and tunnel. Transport mode encrypts only the data inside the message but ignores the header. Tunnel mode is more secure since it encrypts both the header and the message. Security is also available at the application layer with a protocol known as Pretty Good Privacy. PGP uses a public key system in which each user has a public-private key pair. For creating digital signatures, PGP generates a hash from the user's signature data. This hash code is then encrypted with the sender's private key. The receiver uses the sender's public key to decrypt the hash code. If it matches the hash code sent as the digital signature for the message, then the receiver is sure that the message was sent by the stated sender and was not changed. Network protection. There are several facilities that can be used in a network to improve security that are not actually inside an OS but impact the security features inside an OS. Most homes and organizations that run a local area network are connected to the internet at only one point. This one connection is an ideal point to inspect communication messages for various problems. The facility that provides this function is called a firewall. This is embedded in the router that connects to the internet, since the router is looking at the packets anyway. There are several functions that a firewall can do. First, it can block certain types of connection altogether by looking at the port numbers used by the connection request. It can also inspect the insides of the packet and disallow certain types of traffic. Some firewalls are also configured to disallow traffic from IP addresses that are considered to be unsafe. Firewalls can be supplied with signatures, data associated with specific attacks. They can also include a traffic monitor that watches for patterns that indicate a significant deviation from normal traffic patterns. One problem with firewall at the network connection point is that not all machines in the network need to be of the same types of connection. It is common to also provide a firewall function in a personal computer that will disallow some sessions. It often is configured to disallow many outbound connections as well as inbound connections, since a common technique of many viruses is to connect to rogue hosts to report stolen information. A local firewall will be an application program rather than a part of the OS, but in order to inspect the connections that are being requested and the traffic coming and going, they will need to be able to insert their functionality in the protocol stack. There are several things that a system administrator must do to ensure the security of the system connected to a network. First would be the log of failed login attempts. A small number of failed logins will be normal. Users sometimes type something wrong or use a password for some other account. But sometimes a spike in the number of failed logins should be an alarm, which is indicating penetration of a system, and hence this must be logged. Some systems have substantially higher security requirements than do others. A home personal computer probably needs little security beyond keeping out viruses and hackers. A bank needs much more security as it involves money. A hospital system needs even more higher security as it can be a matter of life or death. A military service should be given a very high security as a failure might put millions of lives at risk. With each higher level, the OS must provide extra features, many of which are in the area of logging of activities. We don't want to load down the OS of a personal computer in a home with all the features necessary for security on that military system. The lowest level is D, which has minimal security. A system with this level of security might be used by any user in an office or in a home. Now, there are many different types of security. First comes Type C, Type D, Type D, which is the lowest level. Then there's Type C. Type C provides protection and user accountability using ordered capabilities. It is of two types, C1 and C2. C1 incorporates control so that users can protect their private information and keep other users from accidentally reading or deleting their data. C2 adds an individual level access control to the capabilities of a C1 system. Then there comes Type B. Type B provides mandatory protection system. have all the properties of a class C2 system and also attaches a sensitivity label to each object. It is of three types: B1, B2, B3. B1 maintains the security label of each object in the system label and is used for making decisions to access control. B2 assigns the sensitivity label to each system resource, such as storage objects, support covert channels, and auditing of events. B3 allows creating lists or user groups for access control to grant access or revoke access to a given named object. Then there comes Type A. Type A is the highest level. It uses formal design specification and verification techniques, grants a higher degree of assurance of process security. Our general computers on normal operating systems are of class C2 system. This was the basic. Thank you for listening. Thank you.